All right, so we're going to look at balancing some chemical equations, and these are a little harder than the ones we've done before. A lot of these have polyatomic ions in them, and remember that polyatomic ions come from your chart in your reference table. So these are all the polyatomic ions. So it's a group of atoms with a charge. So it'll give you the formula like nitrate is NO3 with a -1 charge. All right, so the first one is sodium hydroxide and hydrogen sulfate react to form sodium sulfate and water. So this has a compound with two things in it, sodium hydroxide, hydrogen sulfate. And so that's going to be a double replacement reaction. Because you have two things reacting, and basically they just switch endings. So this one bonds with that one's ending, and that one bonds with that one. Anytime you see an H bonding with an OH, it's going to form water. All right, so let's balance this. If we look here, we have 2 sodium, and over here we have 1 sodium because there's nothing after it. So we're going to put a 2 in front of that. I would suggest when you're balancing equations to use a pencil because you will be erasing stuff. All right, so that 2 coefficient multiplies through to everything in the equation. So we have 2 sodium, and then that changed this to 2 oxygen and 2 hydrogen. Okay, so remember when you're balancing equations, you want the same number of elements on the left-hand side as you do the right-hand side. So we changed oxygen to 2 and hydrogen to 2, but we've also got 2 hydrogen here. So altogether on this side, we have 4 hydrogen. Over here, we have 2, so we're going to put a 2 in front of that. So that changed it to 4 hydrogen and 2 oxygen. And then we've got 2 and 2, which is 4, and then 2 oxygen. Notice I did not count these oxygens that are in the sulfate when I was adding up those, because if you have a polyatomic ion on each side, you can count that like it's one thing. So over here we had 1 sulfate, 1 sulfate. So now the equation is balanced. We've got 2 sodium, 2 sodium. We've got 2 oxygen, 2 oxygen, 4 hydrogen. We've got 2 hydrogen here and 2 here, so that's 4. 1 sulfate and 1 sulfate. So it's balanced. Next one, we have sodium sulfide and silver nitrate. So these are monatomic ions. Those are from the periodic table. And then we've got the NO3, which is nitrate, and that's polyatomic ion from your chart. But it's still a compound with 2 things in it, bonding with a compound that's got 2 things in it. So it's still a double replacement. They just switch their endings. And you're going to see it in a minute when we actually write out what the products are. But when you have a double replacement reaction, you're just looking at what elements go together. Like this would be sodium and nitrate. When you write it over here, you'll write sodium and nitrate, but then you have to check the charges to make sure there's no subscripts with it. The subscripts do not carry over, so this 2 will not carry over onto this side. It's just the element. All right, so let's look. We have 2 sodium here and we have 1 here, so we're going to put a 2 in front of this. That changed our nitrates to 2. We have 2. Remember, we can count polyatomic ions like they're one thing. So we've balanced the sodium, but now the nitrate has 2. So we're going to put a 2 in front of that. So now that changed it to 2 silver and then 2 nitrates. And we have 2 silvers. And then we still have the 1 sodium and 1 sulfur and 1 sulfur, So the double replacement reaction, and it's balanced. Next one, we have potassium hydroxide. So that is bonding with aluminum chloride. So it's a compound with potassium and hydroxide, aluminum and chloride. So it's got 2 things in each one of them. It is also going to be a double replacement. So they just switch endings. Potassium will bond with chlorine. Aluminum will bond with hydroxide. Now, hydroxide is a polyatomic ion. It's an OH with a -1 charge. That is from your chart. Hydroxide, remember I told you the other day, is an exception to the IDE rule. When you're doing monatomic ions, usually it's always ending with an IDE. Like this chlorine would become a chloride, or this sulfur will become a sulfide. So most of the time when you see an IDE ending, it means it's monatomic. It comes from the periodic table, unless it's hydroxide or peroxide. And hydroxide is the only one on your chart that you will see. Okay, so let's try to balance these up. We have 3 hydroxides over here, and we have 1 here, so we're going to put a 3 in front of this. So that gave us 3 hydroxide. That also gave us 3 potassium. So we're going to put a 3 in front of the potassium. But we changed the number of chlorine to 3. So we look over here, and that's 3, so it's balanced. Then we just look at aluminum, 1 and 1, so it's balanced. Next one, we have calcium hydroxide and hydrogen chloride, which is just hydrochloric acid, bonded with reacting to make calcium chloride and water. So it's a double replacement. They just switched endings. All right, now let's look. We have 2 chlorine here and 1 here, so we're going to put a 2 in front of this. Okay, so that gave us 2 chlorine, 2 chlorine. It also gave us 2 hydrogen here, and this 2 subscript goes with everything in the parentheses, so that's 2 hydrogen. So we have 2 plus 2, which is 4. So over here we have 2, so to make that 4, we're going to put a 2 in front of it. So now that gave us 2 hydrogen plus 2 hydrogen, which is 4. 2 times 2, which is 4. Give us 2 oxygen. We have this 2 outside that, so that's 2 oxygen. 1 calcium, 1 calcium. 2 chlorine, and 2 chlorine, so it's balanced. Next one, we have copper sulfate and aluminum react to form aluminum sulfate and copper. All right, so we have a compound with 2 things in it and a single element. So this is a single replacement reaction. So now aluminum is going to get the ending of this, and it's going to leave copper by itself. All right, so to see if it's balanced, we have 3 sulfates over here, and we only have 1 over here. So we're going to put a 3. And remember, sulfate's just SO4. We count it like it's one thing. All right, that changed our number of copper to 3, so we're going to put a 3 in front of this. And now aluminum, we have 2 here. We only have 1 here, so we're going to put a 2 there. And just a reminder, if you're ever working it out, and say, for instance, you have a 6, a 4, a 2, and a 6 as your coefficients, it's still technically balanced, but it's not reduced down. If the coefficients can all be divided by something, like 2 will go into all of these, then you reduce it down as much as possible. So just keep that in mind. Sometimes your mind sees stuff and you put a number in there and it works, and then you realize the numbers are big and it can be reduced down. So make sure you reduce it down if it can be. Okay, so the next one, we have sodium and CrO4. So CrO4 is on your chart. CrO4 with a 2 negative charge, that is chromate. And lead chloride. Now, most of your transition elements and some of these metals over here can have multiple charges. Lead is one of those. And whenever you see it written out, it will be shown as a Roman numeral. That will be its positive charge, because remember, all the metals have a positive charge. So the first thing we need to do is look and see what it's going to bond with. So we have sodium chromate and lead chloride. So we've got substance with 2 things in it bonded with substance with 2 things. So that's going to be a double replacement. So they're just going to switch endings. So we know that sodium is going to bond with chlorine. And then we know that lead's going to bond with chromate. Okay. Now, remember I told you the subscripts did not carry over. You have to check the charges to see if there's any subscripts that you need. So sodium's charge is +1. If you don't remember how to find those, everything in this column has a +1 charge. Second column has +2. Skip these. These have a +3 charge. These have a -1 in group 17, group 16. These have a -2, and group 15, these have -3. So chlorine was in group 17 as a -1 charge. Lead is one of those that we don't know what the charge is. So we're going to have to figure it out based off of how it bonded with chlorine over here. We do know that chlorine's charge is -1. So there's 2 of those. So overall, this had to be a -2 charge altogether because we had 2 -1 particles. So since there's only 1 lead, that means that it had to have a +2 charge. So if you saw this written out, it would say lead, Roman numeral 2, chloride. So that Roman numeral 2 tells you that lead in this compound has a +2 charge. All right, so lead has a +2 charge, and we're going to look back at chromate. It has a -2 charge. So those charges equal out, add up to 0. So we don't need any subscripts for any of these. So it's written out how it needs to be. Now we need to check to see if it's balanced. So we have 2 sodium here and we have 1 here. We're going to put a 2 in front of that. Okay, and that made us have 2 chlorines, 1 chromate,